Okay, C495 and all structural engineer or lover, and try to create another example playing with the Rhino Grasshopper and SAP. So what you see now is something lattice or X-brace structural model. I think I'm just showing you rendering, so I'm gonna delete it. I'm gonna get started. So let's see. So this is what I have. So this is pretty simple scripting. I'm gonna turn off this rendering and start from the scratch. So I'm gonna turn up and brief introduction. I think this is some, I hope everybody enjoy for future structural engineer and designer should learn SAP, Rhino and Grasshopper for their geometry generation with a parametric tool like Rhino and Grasshopper, especially Grasshopper. This part of also coding, but it's a visual basis, visual scripting, right? So when you get used to it, I think if you also learn Rhino as well, I think you maybe get kind of understanding much faster. So I think probably you most already know it, how to draw the 3D model, right? So just define your reference XY plane. You know how to draw the circle. In order to draw the circle, you have to provide the radius. I provide 3 different radius. Basically, I copy vertically, right? And so this one I'm gonna turn on. So I move this 3, right? So I'm gonna I draw the circle with various radius, and I draw and copy it and roped. So roped is something that each multiple curve you kind of sweep and generate the surface, right? So up to here, if you want, you can play around some, the parameters, radius, and playing around the radius, and then you just explode the geometry, right? So assume this is, I'm gonna use this geometry. I set the unit feet. I think total height is here as tall as 100 feet tall. And with this surface, I'm using some Lunchbox, the structural plugin especially. Maybe I'll try to use this grid, one single brace frame, the component. So I'm using from this Lunchbox structural component here, right? Here is a brace grid. This is basically this one. And subdivide and horizontally, vertically. I use 10 feet vertically and horizontally. Maybe horizontal. Let me see. This is vertical. Yeah, vertical. I just set the each floor is 10 feet. The horizontal, maybe since the span is too long, maybe try to double it, 20. So make this panel as a little bit smaller. All right, so I already have all the subdivision and by using this plugin, and also I grab some curve, and I have to think about how to export it separately so that I can easily handle that group of members. So first, so curve, right? So you see that vertical primary line, I think representing vertical and horizontal. So I'm gonna create and bake to the layer 1, right? And then based upon the all this subdivision, I'm gonna have, I like to bring this surface. Let me turn on this, right? I'm gonna bake this so that I have all geometry. Diagonal, I'm gonna export separately so that I can select and assign the section property more base kind of group so that I can easily handle assigning the section property. So first, I'm gonna export this file to by using IGS file. So tower 1 is a fit. Okay, I export it, right? And then I'm gonna delete it, or I'm gonna export the reference brace frame bracing line. I'm gonna bake int, right? So I'm gonna separately export. This is right, so that I'm gonna import separately. So here is a model. I just open it. I switch to the fit. I'm gonna import IGS file. Oh, and I'm gonna open the first this one, right? And select both. Yes, so let's check. So I brought all the line and surface. Let me see, do I have a surface? Did I export? Yeah, right? So there's the surface. Now, what I'm gonna do, because SAP doesn't continuously adding, let me just, can continuously import. So what I'm usually do, I open another SAP, and then I'm gonna set the fit. I'm gonna import diagonal members separately. So import IGS brace. So this is only a brace line. Why default now? Black and black background output. Use color gray. Reset all output. No, not output. I just wanna change background color display. Yeah, white. So it's a fit. So this is only diagonal members. So what I'm gonna do, because we are handling too many beams members, I need to select and assign the members. But if I import everything at the same time, I have to select each one and assign the member, which is annoying, right? So first of all, I kind of bring some members section properties. This is let's say P5 and 6 and 8, right? I have to set it up the material property, but for now, I just choose one. Oh, right? And then assign this one to P6, 6-inch pipe, right? And what I can do is I can select and hide it, remove from the view, okay, and open the other. Oh, I didn't import yet. Hold on. Let me import IGS, the diagonal bracing. I'm gonna import this bracing member, right? And then I'm gonna grab this old geometry and copy. Oh, where is another? Okay, here. No, which one is which? Show all. Okay, this is only this, right? The other one. Oh, actually, okay. So I actually closed it. So this one, I'm gonna, okay, delete it. Frame. Oh, yeah, nothing here. So this is the one is a brace frame model. The other one, have to delete. I think I have this all. Show all. Did I delete it? Yeah. Oh boy. Okay. So I'm gonna import again IGS. Yeah, because I'm using a one screen, so a little confusing. So I'm select again. So okay, so this one's for now I assigned sections property importing to using some tube or post pipe P6 P8. Okay, I'm just using one P and assign the section properties P8. Let's say P8. Okay, so I'm gonna save it just in case I don't want to lose it. So now I'm gonna turn, because I don't want to click, so I'm gonna turn off this, hide it. And what else I can do here, I'm gonna grab, copy, because they're all same unit, and open and back. I'm gonna paste here 000, right? So this one I can select by all window selection. I assign the P6 section property to P6. So what that means is if I show all, I'm gonna have all. So all, see that diagonal is P6. Seems P6 might be too big. So I'm gonna here select property P6, right? Maybe make a, need to bring define instead of P6, P4. Okay, I'm gonna use a P4 and I'm gonna change to P4. So I have a P6 is all primary member and P4 is diagonal member. Now I think geometry is ready. You could put this in the XY. You know what? Or I can put in and on plan to 0, 0. It doesn't move because I didn't set up the grid. So okay, it's fine. What I'm gonna do, I put the XZ plane and I'm gonna select all the nodes. I'm gonna assign the boundary condition to pin, right? And now this one doesn't know. So I have the shell elements here, right? This is, I assume the panel or glazing is gonna be attached to top and bottom horizontal members, not diagonal. Diagonal should be independent. So that's why I include the shell for the panel weight calculations for superimposed dead load. So self-fade is self-fade. I can use SDL and live load, no live load here. I will just say wind load. Okay, this is SDL, but they don't differentiate it. So this one, I don't think for now it's generating the wind load here yet, but since I set the load combination, I'm gonna select the area section. I think default, I need to reassign the default section properties, but I select all the area elements and assign the uniform load to SDL 1 kilopascal, which is 20 psf glazing wind load of gravity load. So this is for glazing weight assignment, right? So I assign. Second one, I'm gonna reassign. So wind, in this case, the wind, I'm gonna assign the wind x direction, x projected. Maybe let's say 2. For example, I assign the wind load as well. So how can I say it? This, okay. I'm gonna turn on the node restrain and right. Okay. Now I'm gonna show you turn here area load. I have wind load Uniform load resultants. Yeah, it shows some the my wind load on the surface. I use a surface load, so maybe this is bit. Oh, let's turn on only. I can use this. There are many different ways to show this contour, but I use a uniform load, so this is something is you could turn on and off and see local. Did I use? No, actually I use global load. So okay, so I'm gonna explain later what that is. So I assign per section property. First of all, I import geometry, assign section property, and then assign load. So this is ready to run. So I'm gonna run the model. Ooh, we generate 12 load cases. Okay, so let's check dead load. To the dead load, what will be the actual force diagram? So as you see that because the lattice truss vertical member will experience all the column and diagonal also experience column at the top because of this is circular shape. I think try to open it, so obviously there will be some tension ring is developed, right? So bottom as you go down there will be some compression rings develop. So this is a load distribution based upon their self-weight. But if you see this and okay, wind load might be different because wind is blowing extraction. So see that overturning effect. Windward you see the tension side, tension forces. The leeward backside you see the compression side, right? So you could see this is a kind of general kind of workflow how to use the Grasshopper parametric tool to generate the geometry, and those geometry you can separate export layer by layer because you need to, once you export all together, eventually you need to click each member that you wish it to have same there based upon their group, and you have to assign the section property, but that are really annoying. So I usually export separate in the separate group, and by doing that I can easily select all the group and assign the section properties. So let's see here, wind load deflection, and I'm generating an animation. See the formation shape due to the wind load. Okay, sounds good. All right, so I think I'm gonna stop here. I'm gonna put together here with some actual general load diagram, and hope you can learn and enjoy this work flow. Okay, goodbye.